Okay, so what we have here is we have our 8-channel 5-series mixed signal oscilloscope with the inverter motor drive analysis software package. And we're doing a little bit of analysis on a Texas Instruments C2000 microcontroller motor drive 3-phase BLDC motor. So you see here on the scope we've got 3 current probes and 3 differential probes hooked up. Each of those are set up to different lines that are coming out of this controller board over to our BLDC motor. The 3 current probes, one is on each phase, and then the differential probes are hooked up to any of the voltage outputs. Here on the scope you can see the user interface where we've got the 3 differential voltage lines that are overlaid over each other. So that's channel 1, 3, and 5, and then the 3 phase current measurements here on channels 2, 4, and 6. On the left side we have the phasor diagram, which is showing the voltage in the solid vectors and the current in the dashed vectors here. And then this analysis here was done on the startup of the circuit. Let's go ahead and take a look at what that would look like really quick. So I've got windows on this scope, so we're able to control the motor drive here via the USB cable and the GUI that Texas Instruments put together. I've turned the motor off. I'm going to set up one single acquisition here on the scope. Let's jump back over to the TI GUI, turn the motor on, and my horizontal settings I've got set up for a 10-second acquisition. So right here we can see that the scope is triggered and it's acquiring 10 seconds of data right now. The motor's turned on, and we're going to go ahead and look at what the startup of that motor looks like. This measurement badge over in the right has a whole bunch of measurements for the 3 different phases: power factor, apparent power, current and voltage, RMS measurements there. And now the whole signal's come in and been acquired, and we can see what the behavior looks like across the signal. And take a look at what this signal looks like across time. So over here we've reached steady state. This is once the motor has reached the RPM desired, and we can see that this changes over time. Really interesting behavior at the beginning as the motor is initially turned on. You can see both the currents and the voltages are trying to figure out exactly what order they should take within the 3 phases to get to a steady state behavior that's desired. Go ahead and check out the IMDA demos online. Call your account manager if you have any questions.